Hi friends, in the last video we discussed about what a model is. What does a model contain of? We saw a simple model called AlexNet. What are the different names of the model? What are they called? Neural networks, deep learning architectures, models, right? And we call it as a function with nested functions, right? The third step of the four key steps towards deep learning is how do you train the model? What does training a model means? This is almost like this is the most important part of the entire training cycle, right? Next to preparing the data. So what do? We pass in a batch of images that we prepared in the first step to the model in the second step, and the model generates output. As we discussed last video, the outputs that the model generate are random in nature when the input is passed for the first time. We take the output of the model and pass it to the loss function. What is a loss function? A loss function tells the model how bad the model's predictions are. Let's say instead of identifying image with a melanoma, it identifies it as non-melanoma, non-malignant, right? Then it gives a very high number. Basically, it penalizes, just like how you write an exam. You write a wrong answer, then you get a 0 marks, and when you write a correct marks, you get high score, right? In most of the loss functions does it in a reverse way. When the model predicts wrongly, the loss is higher. When the model predicts correctly, the loss is lower. All right. What is a loss function? What exactly happens? The mathematical formulation, we can discuss it in different set of videos. But at a high level, most of the deep learning model outputs are passed to a loss function, which gives you one single number, mostly which tells you how bad the model predictions or how good the model predictions are. So once we get a loss, that alone is not enough, right? We have to tell the model to adjust itself in order to decrease this loss, right? And this process is called backpropagation. We'll not get into the details of what backpropagation is at this point of time, but at a high level, the process of telling the model that it has to adjust and how much it has to adjust to reduce the loss is done by a algorithm called optimizer, and there are several optimizers like SGD, ADAM, and many more in this active area of research. Let's not get into that. So in terms of code, this is all it looks like. In the first step, we get a model, and the second step, we train the model. That's what the fit function here does, right? And the process of creating a loss and giving a feedback is done several times till the loss reduces, and the evaluation metric, the metric which we are concerned about for the given problem, is to an acceptable level, right? And the number of times we repeat is called epochs. So we saw the four key important steps to deep learning. The first three steps are put in the code for the particular Kaggle competition. The first four lines of this code represents preparing data. That includes reading a file which has got our training data. The second one is splitting them into trained data and validation dataset. Validation dataset is not shown to the model, so the predictions of the model on the validation set are used for evaluation to tell how good the model is, right? And the second step here is getting the model. We define a model, and then we set up something called learning rate, weight, decay. Let's look at it a bit later, but these are like parameters that we can tweak to improve the performance of the model. There's certain feedback that is provided by our optimizer, but there are certain feedback that we have to provide to our model training. That still there's a human element to it. And then the last line is where the training happens, and the 10 rep here represents the number of epochs you want to run this model, right? And we provided with the model that we want it to be trained on, and the training data and the validation data and the optimizer, let's look at it on a different video. As we can see, the training loss keeps on reducing. The validation loss kind of reduces and fluctuates because this is where the model has never seen the data, right? The model is predicting on unseen data, and the way we have split it is that validation contains 1.8% of malignant, just like our total data set. We keep the ratios intact. As you can see, the val ROC starts at 8.5 and it goes to 9.128, right? And that means that the evaluation metric that we are concerned about is consistently increasing. So what evaluation metric is something which we did not cover, right? An evaluation metric is something which tells us how good the model is in terms of a business. What is a loss then? Well, loss is something which is particularly used for optimizing the model. There is a small mathematical element to it why we cannot use the evaluation metric as a loss, which we will look at it at later point of time. It's too much to digest at this point of time. And the last step that which we have is generate predictions and submit to Kaggle. We will come to this particular topic once we build all of these three elements from scratch. So there are a lot of concepts that goes into building these concepts called get data, get model, and fit function. Primarily you build a data set, PyTorch data loader, PyTorch model, some model like Efficient or ResNet, and then a training loop. In the coming videos, we'll look at each of these smaller aspects or smaller components that build the entire pipeline. And at final, then we will look at how to generate submissions to the Kaggle competition to see how you perform in the Kaggle competition. And we have provided the entire code as a Kaggle kernel for you to experiment with. We'll provide the link in the description. We'll also provide you the notebook as a Colab for you to experiment with. To start with, if you have come till here, you could make a lot of changes, like you could change how much augmentation you want to change, right? So augmentation is we have not discussed about augmentation, but let me give you a very high level view of augmentation. Augmentation is a technique by which you increase the number of training samples. What exactly you do? We can just take a quick look at it. Basically, we're telling our pipeline to generate images at random by flipping the images, or it can randomly rotate. It can change the brightness of image. The basic idea is we try to cheat the algorithm, saying that this image is different from a slightly rotated version of the image. So the model tries to learn more generalized version of it. For you to play with, you can change the augmentations that are applied here. You can remove some of them, you can add more of them, you can increase the probability by which it's applied. You can try a lot of things here. And for this particular kernel, we gave a B5, which is a bit heavier model. You can start with B0 and you can get a similar score close to 9.925. We have used a particular fold here. You can try to change the fold. There are a few things, if you have already done some part of deep learning, which you can experiment with. If you have not done, if you're completely new to deep learning, all you can try to do is try to set this up in the Kaggle or Colab environment and try to execute it once before we upload the rest of the videos, so that you are much more comfortable. You have already run a pipeline, you understand what the high level pipelines does, and the next few days, in the next week, you will learn what each component of this video does. This is what we're going to look at in the coming videos. Thank you guys. If you like this video, hit like and subscribe, and leave in the comments what you want us to explain more, whether you liked our videos. Is there any particular topic that you would like us to explain more? Thanks guys, thanks for watching, thanks for trusting, and thanks for staying with us. Bye bye.